All right. They have some given information right at the beginning for us. It says if angle HAM and angle YMA are right angles and HM is congruent to YA. So let's go over to the picture and we're going to mark these things to start with. So HAM is a right angle, and YMA is also a right angle. And HM is congruent to YA. Okay, so this is starting to get a little confusing because these triangles are kind of on top of each other. So what I'm going to do is I'm going to redraw these triangles so that they're not right on top of each other. All right, so here's one of them. This is HAM. And so I have this right angle in the corner with HAM. And then, nope, that's not what I want. Let's do the other triangle. Here we go. This is YMA. And we have a right angle in the corner. So I'm redrawing them so that they're not on top of each other anymore. That's going to make it easier for me to mark this because these pieces were overlapping on that original picture. So we have that HM and YA are congruent. Name the part that needs to be proven or stated congruent to use the following. If I wanted to use side angle side, well, there's actually, if you look at this original picture, there's one of the things that we're allowed to mark for free in that picture. What are the two things that we're allowed to mark without being told? Oh, you got it? Cool. Vertical angles and shared sides. Now, most of the time when I see shared sides, I see it like this. Is there a side on this weird picture here that belongs to both triangles? AM. This side down here. AM is congruent to AM because it is the same on both triangles. So if I wanted to use side angle side, well, I have an angle right here, and I have a side right here. So I would need this angle. I can't call that angle M, because looking back at my original picture, if I say angle M, do we have any idea which angle I mean? It could be the right angle, it could be this little angle, it could be this little angle. I have to give it a three-letter name. So what could I call this angle here instead of angle M? Angle HMA, yes. I would say angle HMA is congruent to, now let's look at the other picture. Remember, we want side, oh wait, I'm doing angle, side, angle, my apologies. Let's scoot this one over. I did angle, side, angle. I am so sorry. It said side, angle, side. So side, angle, side. I still need that same angle that we just wrote down. HMA. Angle HMA is congruent to, down here on this triangle to do side, angle, side, here's side, angle, side. Can I call that angle A? No. So what three-letter name could I give this? YAM. We could say angle YAM. All right, so that's if we're going to do side, angle, side. If I'm going to do hypotenuse, leg, first of all, how do you find the hypotenuse of a right triangle? Opposite to the right angle, yes. So here's my right angle. What is opposite this right angle? HM. What is opposite this right angle? YM. We were told at the beginning that those were congruent, right? So that's not an additional piece that I need. I need a leg. Don't I already have a leg that's marked between those? It was one of the things that we said we're allowed to mark for free, our shared side. I need AM congruent to AM. I would need to mark that on my picture. Segment AM congruent to segment AM. Yes. You don't need that on this proof. Try something different. What about if we were doing side, side, side? What else would I need to be congruent? What on this triangle would need to have a congruence mark on it if I was doing side, side, side? Yes, we would need HA. And that would need to be congruent to what on the other triangle? YM. So we would need HA congruent to YM. All right. What about if we were going to do angle, angle, side? Devin. What about if we were going to do angle, angle, side? There's more than one right answer for this one, by the way. Write your name, date, and time on here. Well, I could do angle, angle, side, like this, in which case I would need this angle right here. On the other triangle, we could do angle, angle, side, like this. So I would need these two angles right here, but remember, I can't give these a single letter name. What can I call this one? AMH or HMA. Angle AMH congruent to, what can I call the other one? Angle what? MAY, angle MAY or YAM. Could I also do angle, angle, side? Would that work? And on the other one, I could do angle, angle, side. Well, I already know that A and M are congruent. Those are my right angles. I already know that AM and AM are congruent. So what extra piece would I need? Absolutely. As long as there's enough time. What other pieces would I have to show are congruent? This is already marked as congruent. This is already marked as congruent. H and Y. Can I call this angle H? Would that be okay? Yes. Can I call this angle Y? Yes. So we could say angle H congruent to angle Y. Either one of those would be fine. What two triangles are congruent? What two triangles are congruent? So they're asking me to write a triangle congruence statement that matches up the corresponding congruent pieces. So we can name this first triangle. I'm going to color it in. I can name that triangle anything I want to. The order of the letters does not matter when I do my first triangle. So what could we call this one? HAM, yes. HAM. is congruent to triangle. Now I have to be careful about matching up the corresponding congruent parts. H corresponds to what on this triangle? Which one? Y, yes. So I'd start with Y. A over on this triangle, that's my right angle, corresponds to what on this triangle? M. And then this little angle M on this triangle corresponds to what on my white triangle? A. So triangle HAM is congruent to triangle YMA. Very nicely done. What else would you guys like to look at? What other problems would you guys like to look at? Number 8? Absolutely. Yes. Number 5? Yep. Let's do 5 since we're right here, and then we'll go look at number 8 together. Number 5, if the following statement, AB is congruent to AB, is used, what property is used to make this statement? What property do we use when we say something is congruent to itself? Reflexive property. That is my reflexive property. All right. Number 8 is the next one we're going to do. Number 8 is a proof. What goes here? The given. What goes here? The other piece of the given. So I'm going to take these 2 pieces of my given information and split it between 2 boxes. So it says segment AC bisects angle BCD, and then it says segment BC is congruent to segment DC. This piece of given information right here is a congruence. It should be marked on my picture. Hold on, I don't know why it switched slides. There we go. This is a congruence and should be marked on my picture. Is this already marked on the picture that BC and DC are congruent? No, then we need to go and add it to the picture. BC right here and DC right here. Is there anything in the picture that we are allowed to mark without being told? Shared side. What is my shared side? AC. So I can say AC is congruent to AC. What reason can I use for that? I'm sorry, one more time. Reflexive property, yes. Reflexive property. They gave me some given information that I haven't used yet. What did they give me that I haven't used yet? Yeah. What do bisectors do? They cut things in half. What kind of an object is being cut in half here? What did it say is being cut in half? Angle BCD. So I'm taking an angle and cutting it in half. If I cut an angle in half, oh, sorry, I need the paper behind it. I accidentally got it. There we go. If I take an angle and I cut it in half, I end up with 2 smaller angles or segments? I end up with two smaller angles. Two smaller angles. So let's go find those two smaller angles. It says AC, here's AC, bisects angle BCD. Here's angle BCD. So what could I call the two smaller angles that are the same size? Not BC, that's a side. I need an angle. AB or ACB or BCA. Or I could call it angle 1. I've got this little 1 in the corner. I can call it angle 1. I can cheat. What angle would angle 1 be congruent to? Angle 2. Let's mark them as congruent. I'm going to say angle 1 is congruent to angle 2. I could give it a 3-letter name. Angle BCA is congruent to angle DCA. There's nothing wrong with doing it that way. They're not a linear pair. They are side by side, but they're not a linear pair because together they make just a bigger angle, not a straight line. Linear pairs are side by side, but together they have to make a straight line. What word did we see up above that told us these two little angles were going to be the same size? Bisects. What kind of a bisector do we have? What was the object being cut in half again? An angle. So this would be definition of an angle bisector. You should have a copy of this. This was passed out 2 days ago. You should have this in your folder. Definition of an angle bisector. What will my last statement be? Triangle ABC is congruent to triangle ADC, coming from right here. Looking at the picture, we can use that to determine our reason for saying these are congruent. What reason can we give? Side, angle, side, yes. We have a side here, and then an angle, and then a side. Side, angle, side. All right. What else would you guys like to see from the test review? Number 11, absolutely. Let's go look at number 11. Number 11, in the diagram below, find x and y. Where is x in the picture? Where is x in the picture? Sides, right here, here, and here. We do not have a rule about what the sides of a triangle add up to. Triangles can be really tiny. Triangles can be enormous. There's no rule about what the sides add up to. There is a rule about what the angles add up to. How much do the angles of a triangle add up to? 180. The only thing I can do with sides is find two sides that are the same size and set them equal to each other. I never add sides together. Never, ever, 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 ever add sides together. So I'm kind of stuck here. I don't know which of these sides are the same size, and I can't just set them all equal. That'll give me something really wrong. I have to figure out which two sides are the same size. So I'm stuck on finding x for right now. So let's switch gears and see if we can find y. What kind of an object is y? An angle. And I do have rules about angles. Do we know any of the other angles inside this triangle? 54. Do I know any other angles inside the triangle? No. But I have this angle here. If it's not inside the triangle, what do we call it? Exterior. This is an exterior angle. Are these two angles, y and 54, exterior angles? No. So what are they called then? If they're not exterior, they are interior. These are a very special type of interior angle. They don't touch that exterior angle. Does anybody remember what we call an interior angle that does not touch the exterior angle? Remote. These are remote interior angles. And when we talked about remote interior angles and exterior angles, when we first learned this theorem, this is the one that I told you guys, I'm so afraid that we're going to forget this one by the time we get to the test. When I have two inside angles, I can't add them and set them equal to 180 because it takes all three angles to be equal to 180. I just have two of them. We add the two remote interior angles. So I'm going to take angle 1 and add it to angle 2. And I am going to set it equal to something, but it's not 180 because that's not enough angles to make it equal to 180. We set it equal to our exterior angle. So that would be the measurement of angle 3. So I'm going to take angle 1, which is y, plus angle 2, which is 54 degrees. I'm going to set that equal to angle 3, which is my outside angle, 108. And now what would I need to do to get y all by itself? We're going to minus. Let's minus 54 from both sides. What is 108 minus 54? What is 108 minus 54? 54. All right, so we found y. That's 54. I'm actually going to add that to my picture. I'm going to say this angle here is 54 degrees. What do you notice about this triangle now? We have two angles that are the same. I have the 54-degree angle up at the top, and then I have this 54-degree angle down here. If I have two angles that are the same, what kind of triangle is it? Isosceles, yes. Isosceles triangles don't just have two angles that are the same. They also have what? We don't just have two angles that are the same, we also have two sides. We got to figure out which sides those are so we know which x's to set equal. How do I find the sides that are congruent? Yes, it's going to be opposite my angle. So what is opposite this top angle? 7y minus 14. This is one of my two congruent sides. What's the other congruent side then? 2x plus 16 would be my other congruent side. So we take 7x minus 14. We set it equal to 2x plus 16. And then we solve this for x. So I'm going to get my x's on the same side first. I'm going to minus 2x from both sides. So that would be 5x minus 14 equals 16. Then what do? Not subtract. We're going to add 14 to both sides. What is 16 plus 14? 30. 5 times what gives me 30? 6. So x is 6. What else would you guys like to see? Which one? What else would you guys like to see? 16? Absolutely, we can go and look at number 16. Problem number 16. All right. So 16 has this weird looking picture here. We have some given information up at the top that we need to use. I've got this and this. What do this double vertical line mean? Parallel. And I told you guys that when we see parallel lines, we draw what shape? A Z. We are going to draw a Z. All right, we'll go draw that Z in just a minute. I want to finish with my given information here. Then it says C bisects both AE and BD. What does bisect mean? Cut in half. It says it's doing that to AE. Well, here's AE. It said that C bisects it, so C is right there. You told me that bisect means to cut in half. When I cut something in half, I end up with 2 smaller congruent pieces. What are the 2 smaller congruent pieces we would have here? AC and CE. Let's go ahead and mark those with congruences. But it said that C also bisects BD. BC and DC. BC and DC. Perfect. All right, let's look at this parallel stuff. I have to go on top of my parallel lines. So AB is one of the parallels. DE is the other parallel. I want to make a Z shape. How many options do I have here to trace over and make a Z-type shape? 2. I could do it like this and make a Z-type shape. Or I could do it like this. It's backwards Z, but it's still a Z-type shape. If I do it like this, what are the angles that are congruent? I would have ABC, this angle right up here, and CDE, this angle right down here. Purple to purple, purple to purple. But we said we could have done our Z the other way, right? I could have done it like this and still gotten a Z. That would be 2 different angles being congruent. What would be the 2 angles if I do it this way? Yep. Angle A right here, which is actually angle BAC, and angle E down here in the corner, which is actually angle CED. That uses all my given information. Is there anything I'm allowed to mark on the picture even though it wasn't given? Vertical angles. The vertical angles are centered around what letter in the picture? C. Here's one of my vertical angles. Here's one of my vertical angles. All right, so we've got our 2 triangles totally marked up now. I want to ignore the fact that there's like a million lines in the picture. And we are just going to focus on the fact that we have made two triangles right here. I'm only looking at the two triangles as I do this. We want to figure out which of these statements are true so that we can come over and select the right answer over here. So let's look first. Could we use side, angle, side to say these two triangles are congruent? Do I have enough marked up? Yes. Side, angle, side, or side, angle, side. So I can use side, angle, side to say these two triangles are congruent. If statement number 1 is correct, then which one of these can I get rid of? D. That one doesn't say statement 1, and we know statement 1 is correct. Do I have enough to use angle, side, angle? Yes. I can do angle, side, angle, or I could do angle, side, angle. I've got enough to use angle, side, angle. Since both statements 1 and 2 are correct, which other one can I get rid of? A, because that doesn't have statement 2. I need something that says at least statements 1 and 2. So it could be this one. I don't know yet about this one. Let's go check out statement 3. Statement 3 says that we could use side, side, side for these two triangles. Can I use side, side, side? Which side doesn't have a marking on it? AB doesn't have a marking. DE doesn't have a marking. I can't do side, side, side because I have this pair of sides that's not matched up. So I cannot use this. So which one is the correct answer? B. B is the correct answer because we can't do statement 3. Statement 3 is not correct. And statement 4 says the triangles are not congruent, which is not true at all. We've got 9 more minutes, which is about enough time for 2 questions. What else would you guys like to see? 15? Absolutely. Let's go do number 15. Love this question. We actually did one kind of like it already. I have 3 angles marked in the picture, right? Are they all inside the triangle? Which one's not? Angle 3. What do we call this one? Exterior. This is an exterior angle. And according to up here, that exterior angle is 2x plus 9. These 2 angles are inside the triangle. What's the special name for those 2 angles? They are interior. What special kind of interiors are they? They're a special kind. What'd you say? Remote. These are remote interior angles. We call them remote interior angles because they don't touch that exterior angle. Angle number 1 is x minus 10. And angle number 2 is 3x minus 7. What do I do with these now? Add them all up, set them equal to 180? No. They would all have to be interior if I was going to do that. So what do I do instead? Yes. Add the 2 remote interior angles together. So I'm going to add the measurement of angle 1 plus the measurement of angle 2. And I'm going to set it equal to what? The exterior angle, which is the measurement of angle 3. So in the place of angle 1, we're going to replace that with x minus 10. In the place of angle 2, we're going to replace that with 3x minus 7. And in the place of angle 3, we're going to put 2x plus 9. So now we need to combine our like terms together. So I'm going to combine x and 3x. That'll give me what? 4x. And then we combine our constants, -10 and -7. -17, so 4x minus 17 equals 2x plus 9. Now I need my x's on the same side, so I'm going to minus 2x from both sides. So that gives me 2x minus 17 equals 9. Then we add 17 to both sides. What is 9 plus 17? 26. So 2x equals 26. Then we divide both sides by 2. What is half of 26? 13. So x is 13. Is that the only thing we were asked to find on this problem? No, it said find the value of x and the measurement of angle 2. Well, over here, measurement of angle 2 is 3x minus 7. So we're going to replace the x with 13. So 3 times 13 minus 7. What is 3 times 13? 39. And what is 39 minus 7? 32. We're going to put degrees on this because it's an angle. Anytime we find an angle, we put degrees on it. We have 5 minutes left. I have time for one more problem if it's a short one. Anything else you guys would like to see? 14? Let's look at 14. Using the information below, draw and label a diagram. We are going to draw and label triangles Tom and Dan. So I'm going to draw 2 triangles. I want them to look similar because they are supposed to be congruent. We're going to label one of them T-O-M and the other one D-A-N. We're going to mark these triangles up with their congruences now. T is the first letter, D is the first letter. That means angle T is congruent to angle D. Middle letter and middle letter, O and A. So angle O is congruent to angle A. And then last letter, M and N. M is congruent to N. Then we mark our sides. So now I'm not just looking at 2 letters at or 1 letter at a time, I'm looking at 2. T-O, D-A. So T-O is congruent to D-A. Then I do middle and last letter. Middle and last letter. O-M is congruent to A-N. And then we mark our third pair of congruent sides. That would be T-M, first and last letter, and D-N, first and last letter. Then I'm going to add this information. T-O is 4x minus 20. D-A is 2x plus 2. And A-N is 7x minus 12. We want to find x and O-M. Well, this side right here, T-O is congruent to what? D-A. So we're going to take segment T-O. It is congruent to D-A. That means the length of TO is equal to the length of DA. So 4x minus 20 equals 2x plus 2. Get my x's to the same side. So that would be 2x minus 20 equals 2. Then we add 20 to both sides. That gives me 2x equals 22. So how big is x? 11. x equals 11. We still need to find OM. OM is this side right here. What is that congruent to? AN. So OM is congruent to AN. That means the length of OM is equal to the length of AN. So OM is 7x minus 12. So I do 7 times 11 minus 12. What is 7 times 11? 77 minus 12? 65. So OM is 65. All right. Where do you find the answer key at? Canvas. You go to modules. You go to module number 5. You scroll to the bottom of module number 5. You'll find today's date. If you click on that page, you will find the answer key all the way at the very bottom. Test review is due tomorrow. When you come in to take the test, you will turn in the test review. Send me any questions you guys have today during through Canvas, and I will answer those all the way up until the test tomorrow. Have a fantastic rest of your day, guys. I will see you tomorrow for your test.